block of Fluent. And the reason I do it like this, I can have a very clean setup. So like a very clean setup. Now we're gonna hit update because we need to update the mesh because I think it'll be read into the Fluent block. So now since it's updated, now we can open up and start playing around with Ansys Fluent. So what I like to do have when it will show a Fluent launcher. I don't know if you can see this on my end or on your end, but I like to do double precision. And I just like to do 3 cores on the process because it depends on like your computer. If you compare at 24 cores, you could like activate all 24 cores to run the simulation faster. But for me, I just like to do 3 cores. See the Fluent simulation is open now. But first thing we had to go to is models. We got to turn on the energy equation to run it to activate the parameters like, so we can start measuring our quantities. Then second step will be go to material and click fluid. Then we got once we click, first we just to make it easy to click on area will open up to create slash edit material, then go to Fluent database. I like to use H2O water liquid as my liquid. Then we hit copy. Then we hit close. Close. Then we go to cell conditions. Then we're gonna go to click fluid. When we go click fluid domain, we're gonna open fluid domain up and change the material to water liquid and click apply. Now we're going back to materials under fluid and delete air because this is not relevant to what we're doing. Now we can go to boundary conditions, open up the inlet. For this demonstration, I'm going to apply 4 meters per second of velocity magnitude and click apply. Then we're going to go to initialize because we got to initialize the simulation. We're going to do a standard initialization. We're going to calculate it from the inlet. Then we're going to click initialize the settings. Then we're going to go down to run calculation. I like to do like 1,000 iterations. So then we're going to click calculate. There we go. Let's get rid of those. So now that is done. So now we're gonna close up Ansys Fluent, the simulation. We're gonna go back and click for results. Then we're gonna make it click another block. Then we're gonna show solution with results. Then we're gonna open up results. And it will open up the post-processing data. Well, so I'm gonna show you how to like create a contour map of this. So we're gonna go up to the right, go up to the top and look for contour. We're gonna name pressure, contour. Then I like to do the multiple number. I like to do like 50 contours. This all depends on how smooth you want it. Then as we can see the pressure contour go right. So as we can see the pressure contour map of the simulation. Then I like to create two contours, one for pressure and one for velocity. So as we can see, the velocity contour map is presented and we can see the results of it. Now we gotta go to expressions. Then we're gonna hit new. Say we're gonna name it pressure difference. Definition is I like to use area av. So basically, this just gave us the pressure difference at the pressure difference. Basically, the pressure difference is the pressure at the and then minus the outlet to give us all the pressure difference. Now, since we have pressure difference in the program, what we're gonna do use we're gonna right click pressure difference and use that workbench output parameter, and that will dispense our output parameter in the parametrics that we're about to conduct. So you can see I'll re-click parameter sets and go over here. Now, since we just basically did set up the entire mesh independence test, now we have everything we want to record. Now we can start inputting on different mesh sizes. So I'm gonna do 7.9 e to the negative 4.